Today we're going to go over atomic structure. The first thing that we need to learn is what is an atom. So an atom is the smallest particle of an element that retains its identity in a chemical reaction. So basically, in an element, the atom has the same properties as the element does. So what makes up atoms? Those are subatomic particles. So you might be asking, what are subatomic particles? There are three different types of subatomic particles. The first one are electrons, and they are negatively charged subatomic particles. Next, there are protons, which are positively charged subatomic particles. And then there are neutrons, which are subatomic particles that have no charge at all. So electrons can be shorthanded with E to a negative sign. Protons can be shorthanded with a P and a positive sign, and neutrons can be shorthanded with an N raised to the 0. So neutrons and protons are found in the nucleus of the atom, and electrons are not found in the nucleus. They're found in the space around the nucleus. Protons and neutrons also make up the majority of the mass, being much larger and has more mass than electrons do. Electrons are considered very small and have much less mass than protons and neutrons. So we need to know what an atomic number is. The atomic number of an element is the number of protons in the nucleus of an element. Each element has a unique atomic number. In elemental form, this also represents the number of electrons. So elements are arranged in order of atomic number. So as you go across the periodic table, they're going to increase by 1 in its atomic number, which means that there's one more proton as you go across the periodic table. So when we're talking about an atom that's neutral, so there's no charge, that means that they're the same amount of protons and electrons, meaning that the atomic number can also represent the amount of electrons. That's only if it's neutral. If it is not neutral, it's going to differ. So when it's not neutral, we are talking about ions. So ions are atoms that are either negatively or positively charged, have a different number of electrons compared to protons. So if you have something that's negatively charged, that means that there's more electrons in that atom than there are protons. So we're going to have to add electrons to that atom. If something is positively charged, that means that there's less electrons. Something you have to keep in mind, the number of protons is never changing. It's the electrons that can change. Think of it as the protons are stuck in the nucleus, so there's nothing you can do to change that number. But electrons are not in the nucleus, so you can change that number. But you have to be careful because you're only looking at the value of the positive or negative. So sometimes, say if we had sodium, we can have +1. So this means that since it's a positive, so it's positively charged, that means that there's one less electron. So you can either signify that with a plus or a +1. Now if we go to oxygen, a common ion of it is O2-. So here, since it's negatively charged, there's more electrons, and the 2 signifies that there are 2 more electrons. So you're going to add or subtract electrons depending on what the charge is. So now we have to talk about mass number. So mass number is the total number of protons and neutrons in an atom. Something that you need to remember, or something that will help you remember this, we talked about before how protons and neutrons make up the majority of the mass. So the mass number is what consists of the majority of the mass, which is protons and neutrons. So in order to calculate our number of neutrons, we have to do our mass number minus our atomic number. So mass number is protons and neutrons together, and atomic number, what we just went over, is just protons. So this is a shorthand that you're going to see often. So the example that I used was fluorine. So our atomic number for fluorine is 9. The number on top, that's going to be our mass number. So an isotope is an atom that has the same number of protons, but has an altered number of neutrons. So here, this doesn't always have to be 19. It depends on which type of isotopes that atom has. So let's try some example problems. So here we have K, which is potassium, and it tells us that the atomic number is 19. So if you can think back, what atomic number told us was the amount of protons that were present. So if the atomic number is 19, that means that we have 19 protons. And since potassium is neutral here, that means that our electrons are the same number as well. Right now, so we're only dealing with neutral elements right now. So here, it says that we have 5 electrons. So keeping in mind that we're just dealing with neutral, we're going to have the same amount of protons as we do electrons. So that's 5 as well. So if we know the amount of protons that we have, we know its atomic number, which would also be 5. So we can go to our periodic table and look up which element is 5, and that's boron. So why don't you try these next two alone? Hopefully you got the same answer as I did for these. If you didn't, look back over it again. If you still don't understand it, we can go over it in class. Alright, how many neutrons are there in each of the following isotopes of potassium? So we'll do the first one. Actually, we'll do all of these together. And the next problem you can try on your own. So if you remember, the way we found the number of neutrons was mass number minus atomic number. Top number is mass number, and bottom number is the atomic number. So all we have to do here to find the number of neutrons is 39 minus 19. So the number of neutrons is going to equal 20. So that's the amount of neutrons for this isotope of potassium. Let's do the next one. So for this isotope, we do 40 minus 19, and that's going to give us 21. And for the last isotope, we have 41 minus 19, and that's going to equal 22. It's important for you to realize that even though it has the different isotopes of potassium have different amount of neutrons, it does not change the characteristics. What alters the characteristic of an element is the amount of protons and electrons that it has. So as long as we're keeping consistent our number of protons, which is what the atomic number is telling us, we're still dealing with potassium, and it still reacts the same way in chemical reactions. Why don't you try this one on your own? How many neutrons are there in each of the following isotopes of bromine? Hopefully you got the same answer that I did. If you didn't, look back at it again, try it again, and if you don't understand it, we can go over it in class. Alright, so for this problem, we'll do the first 3 together, and you can try the last 3 on your own. So here, we're going to be dealing with neutral and ions. So let's do this first one. So here we see that nickel is neutral, so we know that we're going to be dealing with the same amount of protons and electrons. So the first thing that I would do here is you're looking up for nickel, so look up the atomic number. You can do that using your periodic table. So nickel is number 28. We're dealing with a neutral element here, so our protons is always the same amount as our atomic number, and since it's neutral, our electrons are going to be the same number as well. So if you remember from what we just did, in order to determine the amount of neutrons, you have to do your mass number minus your atomic number. In this case, that's going to give us 30. So now let's do sodium. So sodium 2+ here. We have an atomic number of 11, so we know that our protons are 11. But now we have a 2+. So if you remember, when we have a positive, we're subtracting electrons because there's more positive charge in that atom. So if we're going to subtract 2 from our number of protons, that's going to leave us with 9 electrons. So now, in order to determine neutrons, we do mass number minus atomic number, and that is going to give us 12 neutrons. Alright, let's do this last one. So we have the same number of protons and electrons, which tells us that it's a neutral atom. We also know, since protons are the same number as atomic number, that it's going to be 9. We can look on our periodic table and find that fluorine is number 9. So now we're looking for mass number. So the way we found neutrons in the past was doing mass number minus atomic number. In this case, we have the number of neutrons and the atomic number. So what we can do here is just rearrange that equation and get 19 as our mass number. So these next 3 try on your own. You can use the first 3 as the examples to help you get through the rest. Make sure you got the same answer as I did. If you didn't, try to do it again, and if not, we can go over it in class tomorrow.